Hey, how's it going? Welcome to another MLittleProgramming tutorial. In today's video, we're going to be taking a look at recursive functions in Python, what recursive functions are, how recursion works, and the rules of recursion. Then, later in the video, we're going to be taking a look at a version of writing recursive functions which are called Auxiliary Recursive Functions. Please like the video and subscribe to the channel if you want to see more of this type of content. Let's jump straight into it. So, what is recursion? Recursion in computer science is a method of solving a problem where the solution depends on solutions to smaller instances of the same problem. Simply put, recursion is a function that calls itself. We can think of this like a Russian doll. You keep opening up the doll over and over again, each time finding a smaller doll inside. This process happens over and over again until there is the smallest possible doll with no other dolls inside, ending the process. Recursive functions have some requirements, often referred to as the 3 laws of recursion. The first is that it must have a base case. A base case is the termination point for the function. This is required because without a base case, theoretically, the function could continue calling itself forever. Second, a recursive function must change its state. This change in state must move the function toward the base case. This essentially means that a recursive function must have a parameter, so that our function could call itself with an argument that moves it closer to its base case. Thirdly, and an obvious result of the previous 2 laws of recursion, is that our recursive function must call itself. Recursion, like all programming paradigms, has some benefits and some drawbacks. We'll take the benefits first. Many algorithms can be expressed more elegantly using recursion. This makes your code easier to read by other people, which is important if you're working on a project in a big team. Recursion can also reduce the time complexity of an algorithm. This is because recursion by nature has decision-making control structures built in. This is because a requirement of a recursive function is that it has a base case asking whether the function should call itself again or terminate. However, there are a few drawbacks of using recursion. As I mentioned earlier, recursion can replace logical operators in our code. But recursion can sometimes be slower in its calculations due to the fact the processor has the overhead of maintaining a stack. A new stack is created for every function call, which is a greater overhead than the existing logical operators have. This means that recursion usually uses more memory for the stack than the existing logical operators. With recursion, it is possible to replace anything you write with a for loop or a while loop with a recursive function. Anyway, that's enough of what recursion is. Now let's get on to some examples. A real-life math example is 5 factorial. Don't worry if you don't know what factorial is, I'll explain as we go along. 5 factorial is written 5 exclamation mark. The factorial is all numbers multiplied together between 0 and the number we are finding the factorial of, not including 0. So in the case of 5 factorial, we would times 1, times 2, times 3, times 4, times 5. And so 5 factorial is 120. So if we look at 4 factorial, that is 1 times 2 times 3 times 4, which is 24. There is also a somewhat potential unexpected case if you are new to this, and that is 0 factorial. 0 factorial is 1. There is no need to go into detail about this in this video. It was mainly for the purpose of explaining how to write a recursive function so that we can work out factorials in the next example. So now we're going to hop into pycharm to write a function that can work out the factorial of a number that we pass into it. Now we're going to hop into pycharm to see how we can build an auxiliary recursive function from an existing singular recursive function. Some people find this method of writing recursive functions easier to understand when they're just starting to write their own recursive functions. I know I did when I just got the grips with writing my own recursive functions. Let's use this singular recursive function that is currently calculating the factorial of a number that we're passing into it, and change the function to a recursive function that makes use of an auxiliary functions. Writing an auxiliary function is an additional function that we write, meaning our recursive function is actually 2 functions working together. An auxiliary function is useful when our recursive function requires extra parameters than what we passed into the initial function call. For example, in our factorials function, there comes a point where the numbers we're trying to calculate the factorial of take a long time to calculate. This means that the user of the program may think that the program is not working, so what we can do is inform them that the program is working by printing something such as loading. We are going to move the functionality from getFactorial to a new function called getFactorialAux. GetFactorial will still have the same parameters as we had before, as we are just going to pass in the number we want to find the factorial of. Inside the getFactorial function, we are going to have a variable, printLoading, which will initialize to false. After that, we'll have an if statement that says if the number we want to find the factorial of is greater than 100. Set print loading to true. Under that, from this function, we're going to return getFactorialAux. We're going to pass in the arguments of the number we want to find the factorial of, and the print loading variable to the getFactorialAux function. We'll also need to set them as parameters so our function expects them. From this point, our program works the same way as the previous singular recursive function. The only code left to write is to get this recursive function to print loading upon every iteration. To do that, we can write a very simple if statement, if print loading, then print the string loading. Now when we call the function, we'll call it with the value 3000 so that we can see that our loading functionality in action. So when we run this now, we'll see that the program will print a series of loading statements, and then when it is done, it will print the factorial number as before. The benefit of this method of writing recursive functions is that we can add more parameters to the function that's doing the recursion than the one we pass in the initial call. They work in a very similar way to singular recursive functions. We go from the call to this getFactorial function. Then we call our aux, which does some recursion and then returns a final calculation to our getFactorial function, which in turn returns a value to the place we initially called from. So hopefully that made a lot of sense, and now you can start writing your own recursive functions. Thank you for watching the video this far. I hope you got a lot of value from it. If you'd like to see more Python programming tutorials, there will be a link in the description down below to a playlist of Python programming tutorials. With that said, if you liked the video, if you could drop a like on the video, it would be much appreciated, as it really helps the channel, and subscribe to see new Python programming tutorials every week. Also, if you've got any questions about the video, drop a comment down below and I'll get back to you. Have a great day.